After we released our Phanteks T30 video, quite a lot of people were asking questions why the T30 was beaten by an Noctua NF812s. And thus they also requested to see how we benchmark our fans, because apparently I'm not including it in the video anymore, which is true, I truly don't. So that's what we are going to do today. I will explain to you how and why I am benchmarking my fans the way that I do. This is my Phanteks P500A case, and that's also my to-go case when I am benchmarking my fans. But before we go over the how we do it, let's go a bit back and see how we got here. In the very beginning, we were using an Aza Hive case with a Be Quiet Pure Rock Slim, the little thing with the silver heatsink, and we had a AMD 3600X, I believe, underneath that. And then we had two fans in the front, one fan in the back, and the whole thing went on. Everything was good, but at some point I got fans which were more and more powerful, thus the difference between fans became smaller and smaller. So I needed something new. Then we got at some point the Phanteks P500A, and I started to do my benchmarks in here, so I did a whole new test. But then a really big issue appeared. When you have a case like a P500A, which is really airflowy, and you have a big ass cooler, let's say a Noctua the NHD15 for example, on there, the amount of air that the case fans can provide is a bit, yeah, nobody cares. The cooler is so big that the difference between a very good set of fans and a very bad one becomes basically undistinguishable, and that was an issue. So what I wanted to do is create an arbitrary enlargement between fan differences, and the way that I tried to do that is by taking a Be Quiet Pure Rock 2 and then have two fans in the front, one fan in the back, just as I had before. In this case we just have a 3700X at 3.9 something gigahertz and 1.2 volts V-core. In the end it is pushing around 130 watts. And we use that. The problem, however, that fan differences became so small was still existent. So what I did was completely remove the Be Quiet fan from the heatsink. Basically, it was, let's call it semi-passively sitting there. What happened is that the differences between the fans became substantially larger. And back then, when I tried to test the whole setup and how it worked, I found, because it was a P14 versus P12 and so on, I found that in my benchmarks a fan difference of 5 degrees C was somewhat around 1 degree to 2 degree or half a degree, in that range, in a real world scenario with something like a NHD15. And that was really useful because you have fans like a P12 and a P12 ARGB, where on spec, in a real build, they are identical, but in fact, if you enlarge the differences, there is a difference at some point, but it's hard to see if you have a NHD15 rocking underneath it. So that was where I was coming from, and another little positive point about the P500A case is that I could also mount a 140mm fan in the back and two 140mm fans in the front, which is really good because that way I can one-to-one compare a 120mm fan and a 140mm fan, so everything was quite cool. Another few interesting things that I found with this whole setup is it is not solely testing static pressure. That's something that I see people do a lot when they test fans, where they just slap them on radiators and then they test that. That's a good indication for radiator fans, but in a case fan environment, it is not what you are actually looking for. And I'm just going to put out a blank statement here. Most people who are buying fans are buying them for a case, not for a radiator. The water cooling market is quite small. The custom water cooling market, where you do not buy like an Cooler Master whatever water cooler with fans already on them, or like a custom thing, or you exchange them, is even smaller. So testing fans solely on radiator performance I don't think it's representative of what the market actually does out there. Having that said, that is the reason why I do not test my fans on radiators. I just don't believe that it is a representative value in the end for me as a consumer. The exact same thing for me applies to heatsinks. I don't know one single person who bought an air cooler and then replaced the fan. If it died, okay, but not in a normal situation. I don't know even a single person who did that. And that's okay. And I believe those are niche markets which should be addressed as niche markets. For example, radiators, I believe that should be a completely different topic where I, for example, make a video which is the best radiator fan and I test a bunch of fans, but I am testing for an average number. And that's basically what my test is trying to do here. Because if I would test the fans as a heatsink fan, as a case fan and as a radiator fan, I would end up with 3 different numbers where different fans can be the best fan. And when somebody asks me which is the best fan, I will need to give them 3 different fans. And I do not want to do that. I wanted to create like an average number that explains it for the usual use case. And the usual use case, in my opinion, is a case fan. That being said, based on what air cooler or radiator, whatever water cooler you have, you will need some level of static pressure. That's why I was really happy with the way that we implemented this test, because the theory goes that the back fan, which is basically acting as the heatsink fan, although it is not really the heatsink fan because it is not sticking to it, it is right behind it. I believe that the static pressure that it can produce is still helping it to it is helping it to some degree, but not until the very end. And that's really important, because you have very high static pressure fans, T30 would be an example, which are dominating the radiator market, and that's okay. But in some cases you also want a certain degree of airflow. And that's something that pure radiator tests are kind of neglecting. And what I found in my test is that you have a set amount of static pressure that you can use. That's why I'm so happy about this setup, because it is like what I found until now, it is a representative example in an enlarged way of an actual build. So what we usually do is have 2 fans in the front, 1 in the back, and then we just blow it from pulling in the front, out in the back. We hit it with CPU-Z, the stress test, bench testing, and we just measure with hardware monitor. Then, as you may have seen in the beginning of the video, I still had the T30 attached here on the heatsink, and that is a very good reason, because we did a bunch of tests to see how good our numbers actually work, especially because people started to complain where we have the NF812, which outperformed the T30, and many people didn't believe that, and so on and so forth. So we redid all the tests and we came to the exact same conclusion. We have the NF812 X25 that performed at 39 degrees C above ambient, and the T30 here performing 44 degrees C above ambient. And the noise normalized testing, oh, and by the way, we have the microphone, so the dB meter in the front that is always measuring, and then we, for the noise normalized test, we just take 10% decrements in PVM, and then we write down both the temperature and the dB, and then we create that nice little graph. So our numbers are still exactly the same. Because people started to complain, and Phanteks also wanted us to do an additional test, we did strap one of the front T30s straight to the heatsink. So basically we created a heatsink fan out of it, and we had a T30 in the front pulling air in, so we have the airflow, the case fan, we have the heatsink fan, and we have the airflow take out of the case fan. In that setup, of course, the numbers are not enlarged that much anymore, and they boil down to the amount of air that the central fan can pull through based on what the front fan can push in, and you get the idea. In this scenario, the T30 managed to keep the 3700X at 34 degrees C above ambient. That's substantially better than the 44 from before, although now we have a fan strapped on the heatsink, and that changes things quite a lot. But we also tested the NF812X25. In the same setup, with one in the front, one on the heatsink, one in the back, we reached 33 degrees C above ambient. So we have a degree difference where the NF812X25 beat the T30 in performance, or in 2000 RPM mode, in terms of max performance. And this recreates my initial findings from like half a year ago, where I found that fans which had a real world 1 degree C difference were actually 5 degrees in my benchmarks, and this is exactly the same. The difference between the T30 and the A12X25 is 1 degree C in a normal environment, or a humanly normal environment, and in my benchmarks and large numbers we have 5 degrees C. So the numbers are still correct. One very important little detail. In the past we purchased one of these digital tachometers, those RPM counters, right? And we tested both fans just to see how far the margin of error can push things. And we found that the T30s are actually, all three of them, are spinning at 1975 RPM. So 25 RPM below spec, although still in the margin of error. You have like a 10% margin of error. The A12 and X25s, however, are spinning at 2140 RPM. That's 165 RPM difference. And I believe that this is the reason why the T30s were beaten by the A12s in my particular test. I believe that if the numbers were straight 2000, they would equalize in a case/heatsink environment like I'm testing it here. On a radiator, that's still a completely different story that I'm not getting into right now, but for a normal use case, I believe that they should have been equal, but due to margin of production, the T30s lost. And I can only, and that's my way of testing everything, I am using what I have in front of me, and if it loses due to margin of error due to production, I don't care. That's just how it's going to be. So to go back to my benchmarks so that people really understand it from here, because back in the beginning I always included a little section in my fan benchmarks and my fan tests where I explained shortly in 2, 3, 4 sentences how we benchmark them. But I saw a huge drop in views at the exact moment, at the percentage graph just dropped for a second because nobody wanted to see it. So I just dropped it. Well, this now bites me because people are complaining that they do not know how I benchmark fans, so now I have a video to show them for. 2 fans in the front, 1 fan in the back as exhaust, and it is pushing everything through a Be Quiet Pure Rock 2 in black. Kind of a hybrid heatsink/case fan where we see that the static pressure of a fan is not ignored, and that's really important, but it is also not hyperventilated like on a radiator exam. Our graphs, on the other hand, are pretty easy to read. If you take the max performance graphs, it's very easy. It's a 1 to 5 enlargement. So for example, you have a T30 versus an NF-A12, which is actually just a 5 degrees C difference on my benchmarks, but in a real world scenario, it is 1 degree C. The same goes further down. If you take an A12, X25 and a P12, so an Arctic P12, you have 51 degrees C versus 39 degrees C. A difference of 12 divided by 5, you have a 2.5 in a normal use case. But again, normal use case will always depend on what cooler you have, what CPU you have, what here, what there. But I'm just trying to explain that my benchmarks, those numbers, you can divide, the differences, you can divide by 5 and you will be more exact. But this is the way that I can distinguish 2 very good fans from one another. On the noise normalized benchmarks, as I said, we are doing the exact same thing, but I'm just stepping down the RPM speed in 10% decrements on all the fans, and I'm writing down the dB of my dB beta, which is like roughly 20 centimeters, 25 centimeters in front of the first fan. The way you can read this graph is pretty easy. The bottom right of each, let's say, line will always be max performance. That's the max that a fan can push. And the most left corner of the graph is basically where you want to be, and every fan that is closest to that corner is the best noise to performance competitor with the lines that we have available. And if you take the T30 graph that I showed back then, we can still see the Nokia NF-A12X25 is the most bottom left that exists. And then we have a couple of special cases, like for example the P14, which theoretically outperforms the T30 in a specific portion of the whole graph, but not in others. So in slightly the top left corner, it is better than a T30, although further down, so if you ramp up the speed, it is not as good as a T30. But still, the best corner is bottom left, and the NF812X25 is the most bottom left, though for this graph it is the exact same calculation. I enlarged the numbers. Thus, if we take the real world numbers, everything will be squished almost into a single line, except for really bad fans, and I don't think that's a good point. Of course, not for radiators. This is not a radiator test, nor have I ever said that my fan benchmarks are representative of a radiator. I believe that's a different topic and we should put that in a different video. But for case fans and like overall fans for PC, I think my way of benchmarking is pretty good. If you see any flaw, sure, tell me. Maybe I overlooked something and it needs some improvement, maybe. But yeah, if there are any further questions, comment section, I guess. And at this point, I hope you found what you were looking for, and yeah, hope to see you in the next one. Bye bye.